Hello, you absolute legends. My name is Eric J. Choi, and I'll be going over explainer video 9.2 that goes on about how we're supposed to prove that K Carnot, or I think that's how you say it, is equal to TC over TH minus TC. And into the problem. So this time, our explainer video 9.2 problem is kind of simple, but rather complicated at the same time, because this one line right here, prove that the coefficient of performance of a Carnot refrigerator is K Carnot is equal to TC over TH minus TC, is true. That's it. So reading that, I wasn't really sure how to draw a diagram for the problem, so enjoy a masterfully drawn refrigerator right here. And let's get started off with the problem. So first off, we should understand what K Carnot, if that's how I'm supposed to pronounce his name, is actually. So K is the ratio of heat taken from the cold body or cold reservoir to work needed. So it'd be the ratio of heat at the top, and at the bottom it'd be the work. So first off, I'm going to find the work. The work done by a heat engine is equal to energy added minus ejected, or work is equal to QH minus QC. This is important because it will be referenced later on in the problem a lot. And another formula that we should know is the efficiency of a heat engine is denoted by E is equal to 1 minus TH over TC. I'll kind of explain how another part of the problem will equate to this form later on. Another way to think about E is work out of the system over work into the system, or rather W over Q in. And if we plug in the work from earlier, like I said we would, we ultimately end up with the equation QH minus QC all over QH. Now, this can also be rewritten as QH over QH minus QC over QH. And if we simplify that out, it ends up as 1 minus QC over QH. Now, doesn't this look a bit familiar? I think coincidence, I think not. Okay, that was cheesy. Continuing on with the problem. So if we compare both the equations and equate them to each other, we ultimately end up with something like this. QC over QH is equal to TH over TC. We're going to use this relation later on in the problem, but now that we went through all that busy work, we have all the pieces to actually solve why the K Carnot is equal to QC over QH minus QC. So using K is equal to QC over W, as I mentioned at the very top when we start out the problem, we again plug in that work is equal to QH minus QC and end up with this equation right here. So this can be considered to look exactly like this. So if we put it at the bottom, it'll be divided up into the numerator, but we want it in the denominator so we can simplify it out like this. And now, again with the plug and chug that physics seems to love, we get this relation and plug it into the denominator right here. Now, you might think, oh, isn't this the same as what we had earlier? So we can basically just reverse every single step that we just did earlier to get it to this form by removing the 1 by putting the TC back in the denominator before popping it back into the numerator. And would you look at that? We just proved that K Carnot is equal to TC over TH minus TC. A lot of these problems really tend to love plug and chug and saving certain values for later on in the problem. So when it comes to these kind of problems, it's best to keep track of what values are important and what are not. I hope you guys understood the problem, you absolute legends.